Hello, welcome to week 1, day number 2. I'm Mr. Roll and I'm here with Miss Martell, our first grade teacher.
Hi.
So first, before we begin our day, a couple quick announcements. In week 1, day 1, we tried our very best to have a very long explanation how to get to every single file and every single Khan Academy video or any other video that our teachers were using in the lesson. Starting today, however, we are not going to have long explanations for every cut when we go to a different video or when we go to a different lesson online. You need to make sure that you have the day's list of links in front of you and click through the links in order so that you can go to the next video. Again, yesterday we had a good time explaining everything and taking a long time to do that. But today we're going to streamline it and make it go a little bit faster. So everybody needs to have the list of links in front of them so you can go to the next part of your lesson. All right, that's it for today's announcements. I wanted to talk for just a moment about Mrs. Martell's award-winning SARCEFT first place science fair project. Ms. Martell, can you tell us a little bit about what you and your first grade class did to win first prize at SARCEFT?
Yeah, so the first thing we did was we talked about our body and how we have joints in them. So just in case you don't remember, joints are those little things that help your fingers bend and your whole, anything that bends, that's what's in there. So we created a model hand. We called it our robot hand.
Whoa.
And it was able to move when we did that.
That's really cool.
Yeah, and then we had a whole experiment to see how long it would take to do stuff like write our name with using our joints and then without, and we did a couple of other things too. So,
Ms. Martell, that's so cool. Thank you for sharing. Nice.
Yeah, thank you.
Well, at this time, it's time for our joke of the day and our Pledge of Allegiance. So, Ms. Martell, go ahead.
Right. What do you call fake pasta?
I don't know, Miss Martell. What do you call fake pasta?
An impasta.
Ah. That's cute. Get it? Because it's like an imposter, but impasta. All right. Good times. Miss Martell, if you would, please, let's go ahead and say our Pledge of Allegiance.
Okay. Stand at attention. Place your right hand over your heart, and let's begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you so much, Miss Martell. All right, I guess it's time for us to all get to our classes. We'll see you in a minute.
Bye.
Bye.
All right. Okay, ladies and gentlemen, today is week 1, day 2. And we are in my home office, as you can see. I am ready to go. I got my cup of tea, and I'm ready to do some teaching. So just to explain what's going on, at the Vinci tree, we are trying to prepare just in case the governor puts us all on lockdown and says that we're not allowed to go into the school anymore. A lot of states are already under lockdown. About 70 million Americans right now are kind of like stuck at home unless they're getting groceries or medical attention. And so we want to be sure that if that happens to us in Arizona, we can continue teaching you. So we're trying different ways of teaching. And so that is leading me to teach from my home office. All right. So I'm going to try to keep everything the same, except instead of teaching you standing in front of a board, I get to sit in my comfy chair. I'm also wearing these headphones here, not because I think I look cool, but because they have a microphone on them, and using the microphone on comfy headphones is a lot better than holding an awkward mic. So that's kind of the situation here. Just to let you know too, it's super late, and so if I'm just as loopy as you remember on those days that I'm really tired, that's why. It's almost midnight. Okay, let's go over the agenda for today. So first up, again, it's week 1, day 2. We're going to start with social studies. Now, a lot of you know that we normally start the day with life skills, okay? And so if you love life skills, then rejoice and be happy. Life skills are coming back. I'm hopefully going to start doing life skills as soon as tomorrow. But if you don't like life skills, you're in luck for today because we're not doing it today. By the way, I hope you like life skills because I really do put a lot into that, and I only talk about things that I think are important for you. All right, so first off, we're going to begin with social studies today. For current events, we're going to talk about current events and review yesterday, but today I have a special interview for you, and we'll talk about that in a little bit. Then we're going to review the history that you were supposed to watch last night and kind of talk about the stuff that's coming up today. In literature, we're going to be reviewing the last two chapters. The one that you were supposed to read, Accident and Incident, and then the one before that, the South Pole one that Coach Fryer read to you yesterday. In science, we're going to be talking more about physics and the definition of work. And then in grammar, I believe I saved the clip from Miss Kimmy. And so Miss Kimmy's going to be doing the little grammar lesson with you all. And of course, with math, we have group 1 and group 2. So we are going to pick it up from there. All right. Let's just go ahead and begin. We did a pretty heavy talk yesterday about economies. And so just again to review, on economy is the kind of like the total amount of business in a given area. That's not the official definition of economy, but again, I try to break these down in really simple terms so everybody can kind of understand. We talked about how economies naturally grow, which we call expansion, and then they naturally shrink from time to time, which we call contraction. And the reason why we're talking about this is it is very clear now that our economy is entering a contraction phase. And it's important that you understand what that is and why that's happening and whatnot. And so remember all those terms that we talked about yesterday, and we are coming back to that tomorrow. But today, for our current events, I thought it would be interesting to get an outside perspective on what's happening to the world. A lot of you, again, you're just kind of at home. Maybe you're watching YouTube and Netflix all day. Maybe you're watching TikToks and doing little dances for people. Maybe you're doing the toilet paper challenge, which is basically hacky sack with toilet paper, which right now is in really high demand. So I don't understand that. But again, I'm old and dumb, so maybe I just don't get it. Okay. But I wanted to get an outside perspective. You can read the news and find out what's happening in Italy right now. It's not great. You can read about what's happening in the United Kingdom or Britain. They just locked down today. You can read about what's happening in China. China is actually doing very well, and more than half of the businesses in China have already reopened. And so all of these different places you can read and you can find out what's going on there, except for Africa. There's not very much news on Africa. And so today's interview is with one of my very best friends, and he's actually my business partner. His name is Alan Damulira, and he lives in Africa with his wife and his kids and his 2 dogs. And so I interviewed him over FaceTime, and the interview is very current. And so it took place on Wednesday, March the 25th, 2020, his time in Africa. And so I'm going to cut to that now so we can hear a perspective of somebody from Africa. I hope you enjoy it. Okay, I forgot something really quick. Some of us, not naming any names, could use a little bit of a brush up on geography. So I'm going to do a quick geography thing to talk about where Alan lives before we actually see the interview. Here, this is a cute little town that I like to call Tucson. A couple of you here will recognize where we are at. I can hear Nikki in the back of my mind saying, oh yeah, I know where this is. That's skate country right there. Well, Nikki, if you're watching this video, that's your school right there. So you should know where that is too. All right. Anyway, oh, gross. Look at that. That was before we repainted the walls. It was all red and weird. At least we had green grass. Okay, let's zoom out a little bit here. Okay. So here we are. This is Tucson. Okay. So that little blue dot is us. Let's zoom out a little bit more. There's our beautiful little state, Arizona. Zoom out a little more. There we are, the continental United States of America. Zoom out more. There's our beautiful blue earth. Okay, we crossed the sea here. And as you can see, we have Europe all up on the top here. On the side, we have the Middle East, Israel, Syria, all that good stuff. Okay. And over here we have Africa. All right. So the top portion of Africa up here, where it's all sandy desert, that part is known as North Africa. You have the Saharan Desert at the very top, however you'd like to say it. Okay. over on the left side over here, this is what we call West Africa. Now, in American history, again, we're talking about the Civil War, and most of the slaves that were brought to the United States many years ago were actually captured in this part of Africa along the west. In fact, a big part of the slave trade was right here in Ghana. And then next door to Ghana, we have Ivory Coast, or Côte d'Ivoire, however that is. It's French, I can't say it. And then right here we have Liberia. I just want to remind you guys that Liberia was actually founded by the United States of America. The United States founded Liberia because many, many white people back in the day, when racism was very pronounced, thought that it was best if the races didn't live together. And so they thought the only fair thing to do with African freed slaves or freed African Americans was to send them back to Africa. And so the United States got together and they founded Liberia. And so Liberia, even its capital is, as you maybe remember, is Monrovia, right there, named for James Monroe. Okay, and so when we talk about slavery in the Civil War, we are mostly talking about people who were taken captive from West Africa. At the bottom here, we have South Africa. We have South Africa's, you probably, or hopefully, you've heard of a guy named Nelson Mandela, and he's famous for ending apartheid in South Africa there. We have that country, Lesotho, which is spelled like Lesotho. Okay, moving up the coast, we have Mozambique and the rest. Okay. All right, so we are focusing on East Africa today. My buddy Alan lives in Uganda, right there. Now, if you ever wonder how to find Uganda, it's very easy. If you start up at Egypt, and of course, I hope you all know Egypt for the pyramids and the Sphinx and whatnot, right? We start at the Mediterranean Sea, where the Nile River ends. Okay, and so here we see the Nile River Delta, that kind of triangular shape at the top. And as we move south, so the Nile begins in the south and flows north. It's very unusual in that way. As we follow the Nile down through all of its twists and turns, we go through Sudan, and then we go through the very newly founded country of Southern Sudan or South Sudan. We follow the river's bends through Juba, down over here through Lake Albert, and then eventually we end up at Lake Victoria right here. Okay, so Lake Victoria, and specifically this little bit that goes through Jinja all the way up here to Lake Kyoga, this is considered the beginning of the Nile River. Okay, and so again, to find Uganda, Uganda has Lake Victoria right there. And Uganda is the source of the Nile, or the start of the Nile River. Nile starts up in Egypt, flows south directly down to Uganda, which is Lake Victoria. Okay? Now, specifically, the guy we're talking to is Alan, and he lives in Kampala right here. And just in case any of you were wondering what it's like, sometimes we see on TV, like we see these African villages and stuff like that, that are kind of, they want you to donate money for kids who are not doing very well, things like that. And, that does happen. But I want you to also know that Uganda is like a very nice place. Okay, so here's a cathedral in Uganda. Okay, again, very nice. All right. So if you were looking at these pictures, you might even think it were like Europe or somewhere really nice in the United States. And so Uganda is a very developed country. Okay, they have plenty of rainforest and whatnot, but they also have plenty of civilization, a lot of great people. And so when we talk to Alan, we are not talking to somebody who lives in a hut in the middle of nowhere. He lives in the center of a very bustling city, a city that is larger than the city of Tucson. In fact, it's probably more cosmopolitan and developed than even like the city of Phoenix. So, oh look, there's a Ford Model T in their museum. That's kind of neat. Yeah. Oh, there's some of the huts. This is in a museum, kids. So there's one of the huts that you might associate with, like poor people living in Africa. And this is a historical museum. So that kind of gives you an idea, right? All right. So let's go ahead and jump to the interview. I'm done talking.
Sorry about that, Alan.
That's okay.
Yeah. So what's going on with you guys over there? What's the situation like in Uganda?
Uganda per se is not so badly off. We had managed to keep it at bay for a long time, but over the weekend we got our first case. That was Sunday morning. That came off an Ethiopian Airlines flight from Dubai.
I read about that. Yeah.
Yeah. But then we got other 8 cases that came out on Monday. Yes, Monday. All those other 8 cases were part of that flight. So as of today, we have 9 cases in Uganda, but they're all healthy. They are not very sick.
Oh, good. Has the president shut the borders to cut off any international travel? I know in the United States right now we don't allow any travel from Europe, and I think we've shut the borders to Mexico and Canada. How's Uganda?
Uganda has shut its borders. First, it was first with land, but we kept letting in planes. You know, Uganda has got one international airport, so it's easy to control. There are not many. But when we got the first case on Sunday, everything else was cut off from outside the country, by land, by lake, by air. Nobody is allowed to come in. Nobody comes in, and they limit people that are going out, actually, because even other countries around East Africa have got their own quarantines and stay-at-home advisories.
Wow. Okay. And so even though you only have like 8 cases, everybody is still quarantined at home. Is that right?
Absolutely. Wow. It's a recommendation. It's not being enforced on the streets, but they recommend it.
Yeah, and then with a pregnant wife, you're being extra careful, I imagine, right? So, yeah.
Absolutely.
Yeah, and
Absolutely.
So have you? So I think the United States has actually gotten COVID-19 before you have, and so I think we're at a later stage of the epidemic, but we were not reacting as quickly, it sounds like, as Uganda. So are businesses closing their doors out there already, or is it just a few individuals that are staying home?
When I went to town yesterday. I was doing something. Business looked normal, but people are few. There are not so many, and foodstuffs increasing in price because of the worry. The assurances of the president later in the day made it easier.
Yeah.
But things like essentials, sugar has doubled in price.
Wow.
Yeah, salt was going for, let me calculate, salt was going for something like 0.2 of a dollar, and it went up to 1.2 of a dollar.
Whoa, so it increased like 600%, right? Or 600%.
Absolutely.
Wow.
But
why are those things increasing, if you don't mind me asking? Are they imported from other countries, and so people plan that they won't be available when the border shuts?
We don't import sugar. We actually export sugar.
Yeah, that's what I thought.
The demand from other countries is higher.
Oh, wow.
So the pressure on the factories here is much higher because we have problems in Tanzania, problems in Kenya, which are net importers of our products.
Yeah, is that your German Shepherd back there?
Yes. No, it's not a German Shepherd. German Shepherd, it's half a sheepdog.
Oh, nice, yeah. Well, so I had maybe 2 or 3 more questions. I know we're eating through a lot of your cell data, so thank you so much for letting me do this with you, Alan. So when it came to pass in the United States here, we had a lot of people buy paper towels and toilet paper, so much so that most of our grocery stores and most of our I guess common stores, general stores, they've been sold out of toilet paper and paper towels for a long time. The toilet tissues and anything that you'd use in like a water closet. Has the same thing happened in East Africa?
Not really. We are different. We're kind of different from you because we live hand to mouth, organic. The food comes from the garden, as you may know. What has been happening is there's been increased supply of food from the villages to the cities and towns, but the essentials that we get off the shelves, things like toilet paper, we still have supply of those. There has not been panic buying per se. And that's our worry, because we think that based on what we are seeing in the West, people are not taking this as seriously as they should. Maybe because we haven't registered many deaths in Africa, apart from yesterday when a prominent musician in Cameroon passed on from this disease, from COVID-19.
But wasn't he in his 70s or 80s, I thought?
Come again on that?
Wasn't that musician very old? I thought he was... Was he the one that I heard about? I heard that there was an African musician who was like in his 70s or 80s that passed away last week.
Actually, I don't know whether that's the Mr. Dibango, the jazz guy. Yeah, he was on. He was on. Mm-hmm. Then there was a 67-year-old from Congo called Alus Mabele. That one is not known to the West because his music is mostly African, mostly African genre, so you don't know him, but he was very popular here. He was from Congo. Those are the two main prominent people that have passed on, plus, of course, the vice president of Sierra Leone. And apart from that, we don't have so many deaths, especially in sub-Saharan Africa.
Wow. Okay.
Deaths in Egypt, which is the extreme north, and South Africa, which is extreme south.
Interesting. Okay. Well, I think it's kind of funny because I know that, years ago, Uganda was dealing with HIV/AIDS, and I know West Africa, you guys are a whole continent away, but West Africa, just a year or two ago, was dealing with Ebola. And so, I think a lot of people in Africa are like, I don't know if I'm wrong, though, but maybe it just hasn't hit yet. But, yeah.
There's a sense that we have gone through this here. There's a sense that this is not new. I mean, we have gone through HIV. It came and bombed us in our faces. Then we weathered it. Now we got Ebola, which is very, very close to COVID-19, the way it spreads. But even that we weathered. So there's a sense that this is not new. Unlike you in the West, who don't normally face pandemics and epidemics like this.
Yeah.
So that's why we think that we are resilient to the pandemic.
Absolutely, yeah. Hey, well, would it be okay with you if maybe in a couple of weeks we check in with you again to see how things are going?
Absolutely. Why would there be a problem if I'm still alive and
Come on, Alan, jeez. Hey, well, anyway, buddy, I know you and I, we text all the time and stuff like that, but I appreciate you coming on camera for the kids so we could ask you some questions here and whatnot. Well, anyway, you guys stay safe. All my love to you and Patricia and the kids, Christian Tendo and everybody else. So, I better get going. I still have to teach a whole day of classes for my 7th and 8th graders here. But, Alan, again, I really, really appreciate you, buddy. Thank you.
Thank you very much. Thank you very much.
I didn't ask, is there anything else that maybe you think is interesting that the kids might want to know?
I think we've discussed pretty much everything. We have covered all angles of this. Mm-hmm. I don't think, of course, there were myths. There were myths that COVID-19 was a white man disease. And that I'm going to come to
There's a meme.
us.
Okay.
Yeah, and then there was issue, but it has come. So people are surprised it actually came. Then there was a issue of temperature.
Yeah.
People think that it couldn't survive in temperate climates.
Yeah, when it's hot. Yeah, I'm going to take this jacket off. I'm hot, actually.
But now that we're getting it, and the temperatures are still the same. But we also have to remember that it's the onset of the rain season here, which is normally in the temperatures of 22, 23. So that myth has not been fully debunked about temperature and COVID-19.
Yeah.
So maybe that. Yeah.
Interesting. Okay. Well, again, all our best for you guys out there, Alan, and I'll probably text with you later tonight or for you later today. But yeah, thank you so much, buddy. We'll see you in a little bit, okay?
Thank you very much, and bye.
Take care. Bye.
All right. I hope you enjoyed that interview. I'm not supposed to touch my face. One quick point of clarification. I think he mentioned like 17 or 18 degrees at the end of that interview. That was degrees in Celsius, not in Fahrenheit. It's not freezing cold out there. It's really like a rainforest. And so I think 17 degrees Celsius is something like 65 degrees Fahrenheit. So it's really like a pretty nice temperature. All right, well, let's continue on. So let's start talking about history. Last night you were supposed to do 3 Khan Academy lessons here in history. So you were supposed to read over slavery and the Missouri Compromise, which we talked quite a bit about in class. The Missouri Compromise, which helped keep the nation together until we got the Compromise of 1850. Later on, after the Missouri Compromise was broken. And then you should have read about the political battles over slavery in the mid-1800s. Again, we talked a lot about this in class with the 3 guys, Clay, Calhoun, and tip of the tongue, Clay, Calhoun, and Daniel Webster. Yeah, is that right? Yeah, Daniel Webster. So Clay, Calhoun, and Webster. Calhoun from the south. I want to say Webster from the north, and Clay from the west. Is that right? Yeah, I believe so. Sorry, it's super late right now and my mind is blanking. So we talked a lot about that in class. And then the start of the Civil War, secession in Fort Sumter. Again, kids, you remember President Lincoln and the United States federal government held several forts, and Fort Sumter was one of them, but Fort Sumter sat smack dab in the middle of Confederate land. And so Lincoln, he telegraphed to the Confederates that he was supplying Fort Sumter, but only with provisions of like food and water, not with weapons, so they wouldn't attack him, and yet they still attacked. And so that was how the Civil War began. Okay, and so tonight, we need you to read through the strategy or watch the strategy of the Civil War, talking about the strategies of the North and South. Again, I think they use the phrase war of attrition. Remember, the North had way more people. Oh, I just activated the video. Let me turn this off. The North had way more people than the South, but the South were much better at fighting. Okay. So we talk about early phases of the Civil War, including like Battle of the Bull Run and Antietam, and then we get into the Emancipation Proclamation. Now, there's only one thing I want to mention here. Their analysis of the Emancipation Proclamation is really good. And so I want you to read through all of this here, talking about Lincoln's dilemma and how he still had some border states here that were pro-slave, and so he couldn't be super anti-slave because he might risk losing them. And if he lost Maryland right here, he would basically lose the nation's capital, Washington, D.C., which would not be great. Now, at the very bottom, I think one of the mistakes that we make in modern American history is we make out the Emancipation Proclamation to be a little more important than it actually was. So here's the thing. I want to remind everybody, the Emancipation Proclamation didn't actually free any slaves when it was given, okay? It said that if you are currently a slave in one of the southern states that we're fighting against, when we win, you will be free, okay? And so right here, it promised African Americans in the South that under no circumstances would they be returned to slavery if the United States won the war. That is more or less correct. Again, it did not free any slaves at that moment, but it did promise them that they would be freed if the North won. And it was to, again, encourage slaves to help the Northern cause. Now, I also want to point out something, though, that's also very important. The Emancipation Proclamation was a presidential decree. It was not an act of Congress. It was not a law. Presidential decrees are really easy to change because when the next president comes in, he or she can just change it. And so again, the Emancipation Proclamation was not set in stone. The Emancipation Proclamation was something that could very easily be changed if Lincoln was voted out of office. And so the Emancipation Proclamation, again, was largely a symbolic act to telegraph to the South that the slaves at least needed to get on board and help out the North. Okay, and so again, important document, but maybe not as important as a lot of us like to think. But again, please don't write me emails. I know it was important, but again, we also want to make sure that we understand what it actually did and what it actually meant in the time that it was written.
Okay, I'm recording a super official science video right now, everybody, so Please respect the science. So, all right, I am here and I'm about to teach you some science. And no, this is not just my excuse for a grown man to play with toys, although it kind of is. All right, so yesterday we were talking about the physics concept of work. Maybe you understood the video, maybe you didn't, but remember, work is displacement times force. So work equals displacement times force. If I push against this desk and I apply tons of force, but the desk doesn't move, I didn't actually do any work according to physics. So you might be thinking to yourself, what is work good for? What do we actually use the concept of work for? Which is a great question, which was a question that I asked when I was your age. And then again, when I was reviewing the concept here, I was like, wait, why do we use this again? So let me explain what work is good for. Okay, so I have two little cars here. I'm going to put them on my little dots. Okay, they're both green. So let's pretend for a second that both of these cars are exactly the same. They're not exactly the same, but let's pretend that they're exactly the same. And let's pretend that my little rook here, my little castle, that the cars need to get to the castle. And they're exactly the same car, and they weigh exactly the same, and they're the exact same distance from the castle. Everybody follow? Cars to the castle. All right, we're cool. But the cars don't work. And so my friend Evie, there we go. Evie, stand up. My friend Evie has to push the cars to the castle, okay? And so my first car here, Evie pushes the car to the castle. Evie! So he pushes it all the way to the castle. Hooray, he did it, okay? And we can measure the amount of work that Evie had to do to push the car to the castle because we take the force that Evie applied and we multiply it by the mass of this car, okay? And so Evie did the first car, he pushed it to the castle, hooray, he did a certain amount of work. Now let's say that Evie is going to do the second car now, but Evie notices something about the second car. Even though the second car is exactly the same as the first car, the second car is upside down. Uh-oh, okay? So Evie is pushing the exact same car, the exact same distance to the exact same place, but the amount of force that Evie has to use to get the car there is much greater because the car isn't rolling on its wheels. The car is being pushed along on its hood, okay? And so in the second instance, Evie, although doing the exact same amount of mass to the exact same place, did a lot more work because the amount of force that had to be applied was much greater. And so you might be thinking to yourself, well, Mr. Roll, that's like the dumbest example I've ever heard. Okay, and that's fair, okay? That example was kind of unintelligent. I can edit this if I'm not lazy. You're probably watching right now and I didn't edit it. All right, anyway, okay. So using a more realistic example, okay? Say that these cars are not exactly the same, but they weigh the exact same amount, okay? Let's say that car number 1 right here has a very well-built, efficient engine. Car number 2 right here, which weighs exactly the same as car number 1, has a not efficient, not well-built engine, okay? Car number 1 can get from here all the way to the castle using only 1 gallon of gas. But car number 2 here, with the inefficient engine, has to use 2 gallons of gas to get all the way over here, okay? Car number 2 would have used up more energy, and car number 2 would have taken more work to get there because it does not travel as efficiently as car number 1. And so the concept of work can be used to measure efficiencies, to get things done. The concept of work is also very important if you ever become an engineer. I know there's a few of you like Kiara who wants to be an engineer one day for NASA. When we're looking at different planetary bodies and how much work that our robots have to do when we send them to space or other planets, the concept of work becomes incredibly important. The work coefficient is something that is really important. So, to end the super professional, very cool, not dumb at all lesson that I'm giving you right now, I have a video for you to watch, and once you're done watching that video, you should be good to go. All right, well, we'll see you on day 3. Goodbye, everybody.
Okay, good deal. Hey guys, sorry that like every time you see me, I'm somewhere different or doing something weird. We're trying to produce this as quickly as possible, and I think I have a little message about that at the end here. Also, I'm kind of helping everybody else out, so I'm trying to film our lessons whenever I get the time. So let's go ahead and jump into today's lesson. So for Math Group 1, we are talking about the area of triangles today. In Math Group 2, we're talking about solving a system of equations using something called substitution. Let's get into it. Okay, so first up, let me get acquainted here. All right, so we're going to use one of these. Okay, so again, this is for group 1. Oops. So we're on group 1, and so we're doing the area of a triangle. It's a triangle. Okay, so if you think about it, right, if I have like a square, okay, or a rectangle, a square or a rectangle really is nothing more than than 2 triangles. So you see I can cut it up there, and so all of a sudden I went from a rectangle to having 2 triangles. Like I'll show you here. So I can fill it in there like that, okay? So I have a triangle that's colored in and a triangle that's not colored in, okay? So does that make sense so far? A rectangle is nothing more than 2 triangles. I hope that makes sense. Okay. So since a rectangle is really just nothing more but 2 triangles, okay, when I'm finding the area of a triangle, I can use a little trick, okay? So if I have a triangle here, like so, okay, and I want to find the area, and remember the area is just kind of like the measurement of the inside. Measurement of the inside, okay. What I can do is I can multiply the base times the height, all right. And now remember, if we multiply the base times the height, really what we're doing, if we multiply the height here and the base here, we'd be getting the area of the rectangle. Area of rectangle. Okay. Again, the area of the rectangle is the base times the height. Okay. All right. And so a triangle is half of a rectangle. So that if we're getting the area of the triangle, it's the same formula. So area of triangle is still the base times the height, but it's the base times the height times 1/2, okay? Because again, a triangle is 1/2 of a larger rectangle, okay? So the area of the triangle is therefore going to be the base times the height times 1/2, okay? And so let's do a quick example, okay? So if I have this kind of squarish looking rectangle, and this side, let's say it's 4 inches, and this side is 3 inches, okay? And then I have a triangle with the same measurements, 4 inches and 3 inches, okay? The area here, again, would just be 4 inches. I'm sorry, let me go ahead and erase that. Okay. How do I make this go away? Do I just do this? I do. Yeah. All right. So 4, go away. Leave me alone. What did I ever do to you, little doc? All right. Hopefully it'll go away on its own. Okay. So we have 4 inches times 3 inches. So again, 4 times 3 gives us 12. And inches times inches gives us inches squared. Okay. And so this would be the area of that little rectangle, okay? But for the triangle, we would take 4 inches times 3 inches, and then times 1/2, okay? And so 4 inches times 3 inches would give us 12 inches squared. Oops, what am I doing? okay? 12 inches squared, like so. And we'd have to do 12 inches squared times 1/2, okay? And so 12 times 1/2 is 6. So it gives us 6 inches squared, just like that. So 6 inches squared would be the area of that triangle there, okay? So again, 12 inches squared for the rectangle, 6 inches squared for the triangle, because 6 is half of 12. All right, one more example, then you guys are left to your own devices on Khan Academy, okay? So let's say we have like a really goofy looking shape here. So let's say that this is 10 tall and it's 2 wide, and we'll say it's 10 feet tall, 2 feet wide, okay? And then we have a triangle that is similar in dimension here. This is 10 feet tall and this is 2 feet wide, okay? Again, the area of the rectangle would simply be 2 feet times 10 feet, which would give us 20 feet squared, okay? The triangle, on the other hand, would be 10 feet times, or I'm sorry, 2 feet times 10 feet times 1/2, which would give us 10 feet squared. So the area of the triangle here, okay, is exactly half of the area here, okay? And you can, again, you can compare this with this, and you can see very easily that 20 is double 10, and 10 is a half of 20. And so that's how you calculate the area of a triangle. So again, for any triangle, just times the base times its height, and then multiplied by 1/2, okay? Really quick, I can already hear some of you becoming a little bit confused here for weirdly shaped triangles. Let's say I have a triangle that's like shaped like this, okay? And you're like, well, Mr. Roll, like the height is over here, okay? So that's my height. My base is over here, but I don't really understand how this goofy looking triangle is half of a rectangle, okay? So let me use maybe the red here, okay? So imagine that we cut the triangle in half, and then we photocopied it. Half of the cutout triangle would fit right here, and the other half of the cutout triangle would fit right here, making it a complete rectangle, okay? Again, so this half would be half of the photocopied, or this part would be half of the photocopied original triangle, okay? And then this part would be the other part of that original photocopied triangle, okay? So again, no matter what the triangle, whatever the shape is, it's base times height times 1/2. All right, so group 1, you can go ahead and skip group 2's lesson and go ahead and start working on the Khan Academy assignments that Mr. Barbero has thrown up on the system for you, okay? Also, you can check the links at the end of the video to get a load of what's going on there, okay? All right, thanks. Group 2, hold on a second. Is it going? Okay, good. All right, so looking next to group 2. So yesterday we talked briefly on solving a system of equations using nothing but the algebraic method, or it's the plug and chug. We plug it in and see if it works. And as I recall yesterday, I think I guessed 2 numbers on a random system of equations and I just happened to get it right. So plug and chug is the first way. The second way that you can do it, which we learned about last night, is by graphing. Okay, and so we can put both lines, both equations on a graph, and we see where they meet in the middle, and then that middle point where they meet is our answer. Okay, hopefully the Khan Academy videos were very good in explaining that, hopefully better than me. And so today what we're talking about is solving a system of equations using substitution, okay, where we would substitute the 2, okay? And so in typical Mr. Roll style, for group 2, let's go ahead and I'm going to make up some equations for us, and maybe they'll work, maybe they won't. I don't know. Let's find out. So here we go. This is group 2. That's a U right there, okay? Group 2, and we are solving systems. It's harder to write on this than you'd think, of equations. With substitution. Okay, so first up, quick reminder, if we have equations like this, so let's say I have 2x plus y equals 10, okay, and then I have another equation that is x plus 3y equals, I don't know, 21, okay? So if I have these two equations here, they are two separate equations. This is not a system of equations until I add the bracket here. Once I add this handy-dandy bracket, that is how I know that my x here and my x here are actually the same number, and that my y here and that my y here are also the same number, okay? And so remember, we have to have them all in the brackets in order for them to, to work like that, okay? So, yeah, so just reviewing that. Okay, so let's go ahead and take that all away. Perfect, okay? So, on to the system here. So if I'm using substitution, what I'm going to do is I am going to pick a key term on one of the equations, okay? So I'm going to first focus on my bottom equation, and the variable I'm going to focus on is my x, okay? I want to figure out what x equals without actually solving the equation. So I'm going to figure out x in terms of y, okay? So I'm going to figure out how many, I'm going to figure out if 1x equals how many y, okay? And so as you should already know, all I have to do is I have to solve for x using literal algebra and not actually worrying about getting numbers, okay? And so I draw my little wall of fairness there, okay? I take away 3y on both sides, as you guys are known to do. And then I get x equals 3y plus 21. Okay, so x equals 3y plus 21. Now what I have to do, kids, is I take this x value right here, and again, the name of the lesson is to solve equations using substitution. So I take this x value, and I'm going to plug it in or substitute it in the other equation. So I'm going to plug this whole thing in up here, okay? And so I'm going to take this x, and I'm going to write all this stuff where this x is, okay? So let's go ahead and try that out. Sorry, I know I scribbled a lot on this, okay? So now what I get over here, I'm going to solve it right here. I'll have 2, my little multiplication window, or my little parentheses, 2, and then a 3y plus 21, okay, plus y equals 10. So do you see how I substituted this value in here, and I plugged it in right there, okay? So this is actually the same equation as the one up here, except I changed the x value, okay? X is no longer x is negative 3y plus 21. Again, I substituted, okay? So again, if I'm gonna write out the steps, okay, I choose variable in an equation to solve for. Step 2, okay, I plug that variable, that solved variable, into the other equation. So that's what we've done so far, okay? So far we chose the variable x, okay, and I solved for x in terms of y, and then I put that back into my next equation here. And now I need to solve for y. So step 3, I need to solve for the other equation, or solve for the other variable. Okay, so if you're keeping track here, I know we just did a lot of stuff, okay? So here's what I know so far. We know we know that x equals negative 3y plus 21. Okay? Now we need to figure out what y equals. Okay? And to figure out what y equals, we're going to solve this guy right here. Okay? Let's go ahead and do it. All right, so first thing I have to do, I have to distribute or rainbow out my 2. Okay? So we say, okay, so 2 times a negative 3y gives us a negative 6y. 2 times 21 gives us 42. Good. Okay? And by rainbowing that out or distributing that, we no longer need parentheses. Excellent. Okay? Now, I have 2 of the same variables here. So I can combine my negative 6y with my y. And negative 6y plus y gives us negative 5y plus 42 still equals 10. Okay? Next step here, I'm going to subtract 42 from both sides. All right, so I get negative 5y equals negative 32. Oh, I got to make my wall longer here. Okay. All right. Then finally, I have to divide both sides by a negative 5. That cancels out, and I get y. Let's see here. What is our number here? So we have 32 divided. I mean, it's like 6 point something. Let's go ahead and figure this out together. 32 divided by 5. Okay, we get 6, which gives us 32. Drop down 20. 6.4. Okay, so y equals 6.4. So now I know, okay, that, wait, did I do that right? I think I did. Okay. So now I know here that y equals 6.4. Okay, you got that? Oops. Nope. So y equals 6.4. So going all the way back up here, in this system of equations, all right, we know that both of our y's equals 6.4. And again, we know that our x equals negative 3y plus 21. So now all I have to do to figure out what x equals, okay, is I can just plug in 6.4. And I can find out, because remember, we know that x equals negative 3y plus 21, just like that, okay? So I can plug in my 6.4 anywhere I want. I can plug in my negative 6.4, I'm sorry, my positive 6.4. I can plug it in here. I can plug it in here. Either way, it shouldn't matter, okay? So this one looks easy, so I'm going to plug it in on the top equation, okay? So let's use this top equation, and I'm going to drag this top equation down, okay? So I'm going to drag this guy down, 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 down. I'm going to drag it so far down that I forgot what it was. So it's 2x plus y equals 10, okay? So right here, down, boom, 2x plus y equals 10, okay? And again, my y equals 6.4, as you see there. So I'm going to plug in 6.4 for my y, and so that turns this equation into 2x plus 6.4 equals 10. All right. Draw my little line, my wall, okay? Take away 6.4 here, take away 6.4 here. All right, that cancels that out. We get 2x, okay? Now remember, when you're taking away with decimals, even though you can do algebra, don't forget the easy stuff. Remember, you always have to line your decimals up there, okay? So definitely don't forget that, okay? And then we get 3.6. So 2x equals 3.6. Then we have to divide by 2 on both sides. That cancels out, gives us that. And then 3.6 divided by 2. Whoops, 2, 1, 6, 8. 1.8. Okay. All right, so x equals 1.8. All right, so the system of equations that I invented at the beginning here, the solution for them is y equals 6.4 and x equals 1.8. Okay, so again, we took one variable x and we solved for x in terms of y right here. Okay, and then once we figured that out, I put it to the side, and then I plug this back in for y, and then I solve for y. All right, my explanation may not make any sense to you guys, and it could be because I'm bad at explaining this, or it could be that you need to see it more than once in order to understand. Either way, oh, there's a mouse in my face. There we go. Either way, I want you to watch the Khan Academy video. Hopefully the explanation on Khan Academy, if you just don't understand this at all, helps to get it down a little bit more. If it doesn't, if you're still confused after this, try watching this video again and try watching the Khan Academy video again. Again, these systems of equations, we're using everything that you've learned, everything that you've mastered over the years, getting all the way up to this point, and we're putting it all into practice. And so you can't forget a single step, otherwise you're not going to get it right. Okay? All right, last thing before I let you go, because there's always something else. I'm long-winded. Okay? So if you are unsure, if you were like, okay, I just did a whole lot of work that I don't completely understand, in this system of equations right here, I got y equals 6.4 and x equals 1.8. You can always double check just by plugging these values in, okay? So again, the system of equations is 2x plus y equals 10, okay? 2x plus y equals 10, all right? And then the other one is x plus 3y equals 21. This is a system, okay? And the answers that we got are x equals 1.8. Did I say 8.1 earlier? I didn't mean that. And then y equals 6.4. So if you're like, I did all this work, I don't fully understand it, I don't know if it's correct, okay? Again, all we have to do to check is we just plug and chug, okay? We can plug this value in for x, we plug this value in for y, and we see if it works. So let's do that real quick, okay? So 2 times 1.8 plus 6.4 equals 10. Does it actually equal 10? That's our question. So 2 times 1.8 gives us 3.6 plus 6.4 equals 10. And if we do the math here, 3.6 plus 6.4, that gives us 0 with 1 up there. That gives us 10. Boom. Okay. Does 10 equal 10? Yes, it does. Gold star. Okay. Or maybe like a little thumbs up. I can't draw very well right now. We got it. Okay. Yay. Happy faces all around. Okay. Now it's not enough for it just to be able to work on one. We have to plug it into the other. Make sure it works there too, just in case we did something weird. Okay. So it's x plus 3y equals 21. X is 1. Oh, wait. X plus 3y equals 21. So x equals 1.8 plus 3. Whoops. I guess we could do it like that. 3 times, what is it, 6.4 equals 21. I'm going to put my wall of fairness here because this problem is a little more complicated, okay? And I want to get mixed up. Let's take 6.4 times 3 because we're doing this section here first, okay? All right, 12, 18, 19. We have a decimal right there, so that turns into 19.2. So we get 1.8 plus 19.2. We add these guys up, we get 21. All right, 21 equals 21, so they both work, okay? Again, if you're unsure about what you're doing or how to do it, and especially if it's on like a test or if you're actually using math to solve like a real life problem, go ahead and always check your values before you just take it for granted, okay? All right, that's it. Go ahead and watch another long Khan Academy video. Thank you.